Okay guys, so here we're going to look at free response questions and specifically the paragraph length response. So the acronym for what you need to remember for the paragraph length response is ABCD. So A, you're going to answer the question. B, you're going to cite some basic physics. C, you're going to cite information. And D, you're going to draw it all together. Okay, so let's go through all of these and see what these mean. So A, B, C, D. Okay, so the first thing is we're going to answer the question. So when you see this, you're going to clearly and directly answer the question asked. On some problems, students are given predetermined answers. So if you do have that, you might just have to put a check mark next to the correct answer. If you're not given these, then make sure you answer the question in a way that is clear and unambiguous. So here's a couple of do's. State whether something increases, decreases, or remains the same. If given two or more cases to choose from, state which case answers the question, or clearly state that both cases are the same. And some don'ts. Just say that something changes. We need to know how it changes, and talk about how it could be either case or both. You need to commit to one answer. So in some cases, the answer is given to you already. For example, you might be asked, explain why the sun is brighter than the moon, rather than which is brighter, the sun or the moon, and explain your reasoning. In these cases where the answer is already given to you, you just have to skip to the B, C, and D. Okay, so A, answer the question. Okay, so for B, you're going to look at some basic physics. So your explanation needs to include at least one statement of basic physics. You'll know that this is a statement of basic physics because a statement of basic physics is true at all times, every day, and in all situations. Basic physics can be the name of the law, like Newton's third law, or it can be a statement how the law itself, such as when the horse pulls the cart pulls back on the horse with the same force. As a note, basic physics can also be an equation or a relationship, like kinetic energy is 1/2 mv squared. Or if the net force is the same either way, then mass and acceleration are inversely proportional. So a good way to look at this is if you look at the formula sheet, you can see the equations with some basic physics. Okay, C. C stands for cite important information. This is when you point out important aspects of this particular situation that are relevant to your explanation. The cite information sentence should start with the words in this situation, or in case 1, or for the small cart, and proceed to say something about the particular problem you are presented with. If you are presented with 2 or more cases to consider, or 2 or more objects appear in the problem, you should consider doing a compare and contrast. Compare means saying what is the same between the 2 cases, and contrast means saying what is different, specifically in which case is some quantity more or less. And then we have D. So D stands for draw it all together. This is when you take your statement of basic physics and the importance of information that you cited from the situation and show how it logically leads to the correct answer. Depending on how well you do with B's and C's, your draw it together might only be a single sentence. Okay, so one more time, we have the ABCDs. Answer the question, basic physics, cite the information, and draw it all together. So let's look at an example problem. All right, so we have these 3 cases, case A, B, and C. So a ball is launched with an initial speed of 5 meters a second from the top of a building. In case A, the ball is launched horizontally. In case B, the ball is launched with an upward angle of 10 degrees. In case C, the ball is launched with a downward angle of 10 degrees. The diagram shown the initial velocity vector in each case, along with a grid in the background that can be used to estimate the components of the initial velocity. In which case will the ball travel the greatest horizontal distance before striking the ground? So if you note, all these are the same length, so they're all 5 meters a second. So let's go through here and let's look at some basic facts. So the answer to the question, the first sentence you can just say projectile B goes farther horizontally. And then we have just some bullet points here. We're going to put it in an example response down here. But if we look at like why does B go farther horizontally? Well, the biggest case is because B spends more time in the air. So the reason why it spends more time in the air is because if it has an upward velocity, it takes time for gravity to take B's upward velocity away and have it start moving back down. And then we have some basic physics. Horizontal distance is horizontal launch speed times travel time. And then all three cases have the same horizontal launch speed, but since B has a greater travel time and the same speed, B travels farther. So this would be a great draw it all together sentence. So note that here's an example response, and it's pretty short. Sometimes the paragraph length responses will have to be longer than this, but this hits all the criteria. I would just add one thing to this and start off and say projectile B goes farther horizontally, because that would be just a point on the AP test. So here it says it looks like all three projectiles have a horizontal launch speed of 5 meters a second. So that would be cite information from the problem. So the information from the problem says that we have a horizontal launch speed of 5 meters a second. But only B has to go upward before going downward. Again, citing information. That extra time going upward means B spends more time in the air. By delta x is equal to Vx delta t. So this equation right here, greater projectile time results in greater horizontal distance. This is your basic physics. So if you rearrange this, look at what this says. The velocity is just equal to delta x over delta t. So basic physics, basic equation. And then the basic concept is that greater projectile time results in greater horizontal distance. So if you have a bigger delta t, then delta x is going to be bigger, because your v of x is remaining the same at 5 meters a second. So if we look at this, we can see I think I made a misstatement up here. So all of these, if you count 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, they all have a horizontal velocity that's equal. The actual velocity, if you take into the y component as well, this would be a longer vector, but the horizontal velocity is all the same. And in this case, since time is more, then it will travel a farther delta x than these guys. Okay, I hope this helps. So take these basic principles and apply them to whatever problem you have. There will always be a paragraph length response in your as one of the free response questions. And so this is just an easy acronym, ABCD. Answer the question, basic physics, cite the information, and draw it all together.